Hello, geometry students, it's Mr. Zabo, and today we are going to do two sections. We are going to first talk about proof by contradiction, also known as reductio ad absurdum, or reducing something to an absurdity. That is the Latin for proof by contradiction. Um, and we are then going to talk about the case of the missing diagram. So let's go ahead and get started. As I mentioned, we're basically taking an argument and we're going to assume the opposite and prove that the opposite is absurd and we can't do it. And so that's the idea. Most cases, the word not or the symbol not or a not equal to, not congruent to is going to appear. That's your indication that you need to do an indirect proof. And so let's talk about the process of indirect proof. We're basically going to be using paragraph proof. For all indirect proofs, we'll be using paragraph proofs. And we'll kind of walk through a quick example here with how to structure those paragraphs, and then we'll do a couple examples with actually writing them. So in here, again, my indication that I know I need to do an indirect proof is that I've been asked to prove that something is not equal. Okay? So in step one, we identify the desired conclusion or proof statement, which in this case is that my triangles are not congruent. That's what I want to prove. And I start by assuming the negation of that. Assume that they are not congruent, or I am going to assume that triangle ABC is congruent to triangle DEF. That essentially is going to be the first sentence in my paragraph proof every time I am using indirect proof. Assume that, and then state the negation of your prove statement. Okay. Then we're going to follow a chain of reasons until we reach an impossible situation, a contradiction of some givens, or a contradiction of a known theorem or definition. So in this case, we have been given that we have been given that angle B is not congruent to angle E. Well, right away, we can stop. Okay. I can write a period, and we can stop because according to my assumption, angle B is congruent to angle E based on their location in my triangle congruence. However, we assumed that, or I can just say our assumption of triangle ABC congruent to triangle DEF shows angle B congruent to angle E. Then we can just basically state that our assumption must be false. Our assumption must be false. So triangle ABC is not congruent to triangle DEF. So I start with the negation of the proof statement. I use logic to come to a conclusion that contradicts something we know is true. We know the givens are true. We know our definitions and theorems are true. Once I state that, I need to write a sentence stating that I have a contradiction, and then my final sentence should always be, our assumption must be false. So state your final exact proof statement. All right, let's do another one together. Again, In this case, I'm asked to prove that segment AS is not congruent to segment AM. I am going to assume that the negation of this is true. I'm going to assume that segment AS is congruent to segment AM. That's going to be my first sentence. Okay, so I write my complete first sentence, then I start looking at what I know to be true in my given statements. Well, I know that AU is perpendicular to SM. That's going to tell me that I have right angles. That's going to tell me that my angles are congruent. So I'm going to know that these are congruent. I'm going to know that this is reflexive, and I am assuming that segment AS is congruent to segment AM. Well, that's going to give me hypotenuse leg congruence. So let's try to write that up. Now, my next sentence, I'm going to say, we were given, so it's kind of my reason first, that segment AU is perpendicular to segment SM, so angle AUM and angle AUS are right angles. I don't need to state that they're congruent, because remember I said HL congruence. So now that I have them as right angles, I'm going to state I have two congruent statements, or a congruent statement and right angles. I'm going to now state that I have the reflexive property. We also know segment AU is congruent to segment AU by the reflexive property. Now I have to state my triangles are congruent. I have congruent hypotenuses at segment AS congruent to segment AM. I have a congruent leg, and I have right angles. So I can state that my triangles are congruent by HL congruence, and therefore, here comes my contradiction, I was told segment SU is not congruent to segment UM, but it is by CPCTC. Segment SU and segment UM, did I name my triangles right? I most certainly did not. Now they are. So segment SU and segment UM are congruent by CPCTC. This contradicts the given. So our assumption must be false. So it states this is the contradiction of this given statement, which must be true because it was given. So our assumption must be false, and segment AS is not congruent to segment AM. And we'll get some practice with that in class. Let's take a look at the case of the missing diagram. We've done one of these problems already in class. Okay, for each of these, we are going to draw a diagram, state given, and prove statements. In this example, it's an if-then form, so what we need to recognize is our hypothesis. The if part of this is going to be my given, and the then part of this is going to be my prove. I think a lot of times looking at it that way is helpful. And maybe draw your diagram first, because however you label your diagram, your triangles with your vertices, is going to impact how you state your givens and your proofs. See if you can draw a picture of what this is saying first, then we'll go back to the givens and proofs. So pause and try to draw a diagram. Okay, so what's important here is not scale, it's that you have a triangle and you have two altitudes drawn. Okay? Now, in my givens, I know that I have two altitudes of a triangle. So I want to state what those are specifically. So I might state that segment BE is an altitude and segment CD is an altitude. What I'm trying to prove is that my triangle is isosceles. So I'm trying to prove triangle ACB is isosceles. And that's it. For right now, we're not going to actually go through and do the proof. We might do that a little bit more in class, but the main focus right now is, can we draw an accurate diagram? Can we identify givens and prove statements? Okay. And again, let's do another one that it's in if-then form. In class, we're going to look at a few that are not in if-then form. And the key to that is, see if you can take your statement and write it in if-then form. Then it's easier to pick out your given and prove. Okay. So go ahead and press pause. Start by drawing a diagram. Then you can write your givens and your prove. All right, so here we go. Again, doesn't have to be drawn to scale. It doesn't have to match my diagram, but it has to be a triangle, and you have to have one segment drawn in that could represent a median or an altitude. It doesn't have to go from A to the opposite side. It can go from C, it can go from B. It doesn't even have to look like a median or an altitude. It just has to be drawn from a vertex to the opposite side. That's the key to understanding the diagram part of it. And then when we are actually writing our givens, it comes from our if, and our prove is going to come from our then. But it does need to be specific. We don't want to prove it is isosceles. That's not specific enough. And we don't want to prove we have a median and an altitude, or we don't have givens of we have a median, we have an altitude. Be specific about what those are. All right, there's going to be a video recap problem I want you guys to try. It's going to be one of each. Let's see how we do and check our work when we get back into class.